So how does one make a difference between what's extremely unlikely and what's impossible? So it's my understanding from what you've just said and from the papers I've read is that the traditional way of doing physics is that you have some initial data set and you evolve it forward. That's like the dynamics. And the constructor way of looking at it is, okay, well, actually, let me go back. What you can do is then look at these laws as some causes that produce some effect. And one of those effects may be that entropy tends to increase. Okay, so in other words, you can derive thermodynamics from statistical mechanics. So it seems like constructor theory is working backward by looking at the effects and then stating those as laws rather than deriving them. So when I hear you say, look, entropy doesn't, or the heat engine, entropy doesn't increase, but well, entropy is not likely to increase. So at what point do we make a cutoff between the likeliness and saying that something's impossible?
Yeah, that's a great question. So let's first consider the fact that when you say that something is possible or impossible, you're not directly referring to likelihood or probabilities for it to happen. So somehow probabilities are not there in the foundations of constructor theory, and they come as, say, derivative statements, approximate things, but somehow they're not necessarily built. In fact, they're not built at all in the foundations of the theory. And this is a plus in a sense. So when you say that something is, a task is impossible, what you mean is that there is a law that forbids the fact that this transformation, these physical transformations that's referred to by the task, is brought about to arbitrarily high accuracy by a constructor. So by this device that can operate in a cycle by returning the substrate that you gave to the constructor in the right input state in the correct output state. And so if the laws of physics say there is some fundamental limit beyond which we can't go as far as this transformation is concerned, meaning there cannot be a full cycle that can operate this transformation and then return itself to the original state of affairs, just like a catalyst would do, that's the case when the task is impossible. A very simple example is the task of changing the energy of a substrate. So if you want to change the energy of a battery, for example, so from low to high, you can't do it with a constructor without any other side effects, because the constructor will have to give up some energy because of conservation of energy. It would give up some energy to the battery.
Yes.
Thereby not being able to return itself to the original state of being able to perform the task again to the same, degree of accuracy. So that's an example of a transformation that's actually possible in the sense that it can happen, it can occur under laws of physics, because obviously we can use another source of energy to replenish the battery once it's on low. However, this other source will have to be depleted itself, so it cannot be a constructor. So now if you're looking for a constructor that can give you energy without depleting itself, you will have to go to a physics where conservation of energy isn't true. And so it's not the kind of physics that we believe describes our universe. Likewise, you can think of another example of an impossible transformation. That's the case of, in quantum theory, we know that we cannot reliably copy any two states of a physical system. This is related to the Heisenberg's uncertainty principle, the fact that you cannot measure reliably any two observables of a physical system. Typically is used, we say the velocity and the position of an electron cannot be both measured simultaneously with the same device. Indirectly, this is a constructor theoretic statement, because it says we cannot have a constructor that can copy or measure accurately these two variables without changing itself in some way. And so it's no longer a constructor, right? So these are examples of impossible tasks, and not that I haven't talked about probabilities there yet. And now if you have laws of physics that, let's say, tell you a number of things that are impossible, but the rest they don't constrain, then whatever is left is a possible task. So if you think of a way of expressing a theory in constructor theoretic terms, you will have a number of statements about tasks being impossible, and those that are not impossible are possible, in the sense that then somehow it's allowed to bring about a constructor that can perform these tasks. And there is where you can think of somehow approximate constructors. So when you're thinking of a possible task being realized, performed, let's imagine a possible task is, for instance, to copy the two values of a bit. So, 0 and 1 can be copied. We know this is possible. We do it all the time, approximately in computers. So, you have 0 and 1 and etc. Now, the fact that the task is possible is a statement about an idealized scenario where you're thinking, okay, that means that there's there are a number of ways of approximating arbitrarily well this behavior of an ideal constructor that can copy 0 and 1 when given them in input.
Yes.
Now, of course, if we look at each particular realization of a copier in any of the computers that we have, for example, they will be approximate. So they won't work perfectly, in the sense that at some point they may break down, they may incur in errors, etc. But this is simply a feature of the fact that we're using limited resources to implement each particular realization of a copier. However, the laws of physics, as far as we know, don't put any limit on how well we can copy. So it means that for each of these imperfect constructors that are approximate, we can work a bit harder, put a bit more resources into the particular device that we have, make it better, so we can meet a better accuracy target if we want to. And so the fact that task is possible simply means there isn't a limitation beyond which we cannot go as far as accuracy is concerned for this task, as far as we know. So these are very different statements from the statement that something is unlikely. So a transformation can be unlikely or more likely, depending on the kind of statement you're looking at. But that would mean simply, for example, that in the standard way of thinking about physics, there is a bunch of possible trajectories that can be realized, as you were saying. And given the initial conditions and what we know about them, we can say that a given trajectory is more likely to occur than another. But that doesn't mean necessarily that there is a constructor that can operate the transformation that corresponds to that trajectory, let's say, of the particle going from A to B. So that's a different statement. The fact that the trajectory is very likely, for example, just means that if we run the system and those are the initial conditions, if we run repeated experiments, we will see most of the times that trajectory to occurring. But it doesn't mean that necessarily there's a constructor, so this device that can work in a cycle to bring this transformation about. So the fact that the trajectory is very likely doesn't necessarily mean that the task associated with it is possible. And likewise, the fact that the transformation is unlikely doesn't necessarily mean that the task
Understood. Yeah.
concerned. Yeah. So, for example, you could say given the initial conditions we have, some transformations that are currently occurring really, very reliably in some laboratories, I don't know, in CERN or something, they're very unlikely, compared to the standard processes, physical processes that occur they're naturally occurring in the universe. However, they are possible tasks because we can simply harness enough energy and enough devices that compose the CERN's labs, if you like, and we can actually reliably bring those transformations about. So even though some trajectories are unlikely, they can correspond to possible tasks. In fact, most of the things we do in laboratories, even in quantum computing laboratories, are very unlikely trajectories for certain entities, certain charges or whatever, fields, etc. And yet we can bring them about really accurately simply because we are following some sort of program to implement these things in the laboratory. So I guess this is a difference between something being likely and something being possible, and likewise unlikely and impossible.
If you enjoyed that clip, then the full podcast is out right now. You can click around here. Enjoy. Subscribe to Theories of Everything to get notified of upcoming podcasts, as there are new full-length podcasts every week on the topics of mathematics, physics, consciousness, free will, and AI.